Hello friends, myself Rajendra Mahajan presenting my video on vector calculus, Green's theorem. Verify Green's theorem. Verify Green's theorem for triangle for f bar is equals to, it is x square I plus xyj over the triangle where C is that triangle whose vertices are 0 to point A is 0 to point B as 2 0 and C as 4 2. For the first step is we have to draw that triangle with that vertices. Therefore, performing or drawing x axis and y axis means Cartesian coordinate system. This is y axis, this is x axis, origin, then triangle ABC, point A with the coordinates 0 2 means that point is on y axis, point B 2 0 on x axis, and C point with the coordinates 4 2. Show it in the figure, or I have shown it in the figure. A point with coordinates 0 2, B point with coordinates 2 0, and C as 4 2. Then making direction anticlockwise means from A to B, then B to C, and C to A. Whenever we have to perform line integral, we have to perform as per the direction. Then shading that region of integration, I have shaded it by green color. Then this is that region of integration for double integration, and making a strip parallel to x-axis from line AB to line BC. As strip is parallel to x-axis, your first integration is with respect to x and then with respect to y when we perform double integration. Then we write down the statement of Green's theorem. Green's theorem states like this: line integration of f bar dot dr bar over the curve C is equals to double integration of dou n by dou x minus dou m by dou x with respect to dou m by dou y with respect to xy. We call this equation number 1. Then we have to find the value of left hand side and value of right hand side. F bar dot dr bar, f bar is x square I plus xyj, a dot product with dr bar is dxi plus dyj. And as per the definition of dot product of two vector, it becomes x square dx plus xy dy, and nothing but the value of m dx plus n dy. And therefore, line integration of that x square dx plus xy dy over that curve C is a sum of the three line integrals. From the figure, this integration is equals to integration along AB, then along BC, and then along CA, and we call this equation number 2. Then to evaluate this line integral along AB, we have to obtain the equation of that straight line AB. Point A with coordinates 0, 2, point B with coordinates 2, 0, we determine the slope as y2 minus y1 upon x2 minus x1. It is 0 minus 2 upon 2 minus 0. Value is minus 1. And equation of that line is y is equal to mx plus c. M as slope and c as the y-intercept. And then from figure, we get y is equal to, slope is here minus 1, therefore y is equal to minus x, and plus c, y-intercept. Here y-intercept is 2. Therefore y is equal to minus x plus 2, nothing but 2 minus x is that equation. Then differentiating it with respect to x, we get dy is equal to minus dx. Therefore, that line integration of x square dx plus xy dy over AB, over the curve AB, is equals to, substituting this information, it is x square dx, no change, and y replaced by 2 minus x, therefore x into 2 minus x, and dy is minus dx into minus dx. And then it is nothing but x square plus x square, it becomes 2x square, and minus 2x. There are two terms, 2x square minus 2x, and its integration with respect to x. And as it is with respect to x, the limits for x, as per that direction, it changes from 0 to 2. Coordinate of x in A is 0 and coordinate of x in B is 2. Therefore, limits are from 0 to 2. It is integration of 2x square minus 2x with respect to x, and integrating it with respect to x, we get 2x cubed by 3 minus 2x square by 2, and limits from 0 to 2. 2 by 3 we take outside, constant term. Upper limit cube, it is 2 cube, it is 8 minus 0, minus x square 2 square 4 minus 0, and therefore 16 by 3 minus 4, finding LCM we get 16 minus 12 by 3, nothing but 4 by 3. Therefore value of that first line integral is 4 by 3. Then we perform along BC. B coordinates 2, 0 and C 4, 2. Therefore once again slope as y2 minus y1, 2 minus 0, x2 minus x1, 4 minus 2. It is 2 by 2, we get 1. An equation as y minus y1, slope into x minus x1. Y minus 0, slope 1, x minus x1, 2. And therefore we get y is equal to x minus 2. As the equation, differentiating it with respect to x, we get dy equal to dx. And therefore, line integration of that x square dx plus xy dy over that BC becomes, it is x square dx no change, x square dx as it is, plus x into y, y is 2 plus x or x plus 2, it is x minus 2. And therefore it is x square plus x square, once again 2x square and minus 2x, and its integration with respect to x, and see how x changes over that BC. It is from 2 to 4, and therefore integrating it we get 2x cubed by 3 minus 2x square by 2, limits from 2 to 4. 2 by 3, 4 cube, that is 4 minus 2 cube 8 and minus in bracket 4 square, that is 16, minus 2 square 4. We get 2 by 3 into 56 minus 16 minus 4, that is 12. Finding LCM, we get 2 into 56 minus 36 divided by 3, and therefore value is 112 minus 36 by 3, and therefore it is 76 by 3, the value for the second line integral. And then lastly, along the line BC, or CA, sorry, equation is y is equal to 2, line parallel to x-axis. Differentiating it, we get dy equals to 0, and therefore line integration of x square dx plus xy dy over that CA. It is not BA, it is CA. Make the correction. Yes, I have made that. And therefore it is equals to x square into dx, and dy 0, that second term becomes 0, and limits from 4 to at point C it is 4, and at A it is 2 or 0. And therefore we get integration as x cube by 3, limits from 4 to 0, and we get it is 0 minus 4 cube divided by 3. 4 cube is 64. Therefore its value is minus 64 by 3. Value of third line integral. And therefore substituting these values in equation 2, we get the value of LHS as 4 by 3 plus 76 by 3 minus 64 by 3. It is nothing but 80 minus 64 by 3, that is 16 by 3. We call this equation number 3. Then we have to obtain a right hand side by double integration. It is dou n by dou x minus dou m by dou y. The value of dou n by dou x is y. Dou m by dou y is 0, therefore that subtraction is y. Substituting that in this double integration of dou n by dou x minus dou m by dou y, we have double integration of y with respect to xy over that region R. And then as per the strip, we have to perform the first integration with respect to x, therefore with respect to x, and then with respect to y. Limit for x R, it is from this we get x is equal to 2 minus y. The lower end is on this line AB. Equation is 2 minus y, and upper lies on the second line. Equation is 2 plus y, and whatever that result is multiplied by y and integrated with respect to y between limits 0 to 2, and then outer limit 0 to 2 as it is y. Integration of dx is x, and limits from 2 minus y to 2 plus y, and then integrating it with respect to y. 0 to 2, y as it is, upper limit minus lower limit 2 plus y minus 2 minus y, and then its integration with respect to y. 2 to get cancelled, y plus y, we get 2y into that outer y, that becomes 2y square, and its integration with respect to y, we have 2 into y cube by 3 between 0 to 2. Therefore it is 2 y cube by 3, and limits are from 0 to 2. Substituting the upper and lower limit, it is 2 by 3. 2 cube is 8 minus 0, and therefore 16 by 3. A value of right hand side. We call this equation number 4. And therefore from equation 3 and equation 4, we have value of LHS and value of RHS is equals to 16 by 3. Same values for both left hand side as well as right hand side, means Green's theorem is verified. We can say that hence Green's theorem is verified. The answer. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you. Thanks for watching.